Today's topic of discussion is gravitational potential energy. Now, see, when two objects close to each other, then produce a gravitational field around them, okay? And due to this, they possess the potential energy. Try to understand whenever you have two objects close to each other, then they produce the gravitational field around them, and because of this, they have the potential energy. When the distance between two objects decreases, the work is done by the gravitational force. Okay, because this is an attractive force, so when the distance is decreased, okay, rather if you are bringing this object close to the first object, then there is an attractive force. So attractive force tries to bring this second object towards the first object, and we can say that the work is done by the gravitational force. When two body going away from each other, then work is done against the gravitational force. Try to understand, when you want to take this away, then there is an attractive force. The second object tries to always move towards the first, and you are taking it away from the first, therefore the work is done against the force. In this situation, gravitational potential energy of the object also changes. Thus, the work done in bringing a body of mass m from infinity to the point in the gravitational field of the other body. Say, for example, you have this body and you want to bring the other object from infinity to this particular point, then whatever work is done to bring this object of mass, say m2, in the gravitational field of this object of mass m1, and whatever work is done to bring this object from infinity to a point in the gravitational field of the first, then that work done is nothing but the gravitational potential energy at that point. When body is at infinite distance from other body, then the gravitational force exerted on this body is zero, because we have the formula G m1 m2 upon r square. When r is infinity, the denominator is very large, then the force which is acting on this second object by the first object will be almost zero. In this situation, okay, or we can say in this situation state, body at infinite distance have zero potential energy, and this energy is known as the zero potential energy of this object. Okay. Now again define gravitational potential energy. Obtain the formula for the gravitational potential energy of the body at distance r, or we can say r is smaller than re, rather r is greater than re, okay, from the center of the earth. Okay. Now suppose you have the mass of the earth as me. So this is the earth whose mass is me and its radius is denoted by re. Okay. You have the another object of mass m, which is situated at some point, say at point P, which is situated at distance r, that is small r, from the center of the earth. Okay. And here the object earlier was at say point say A. Okay, say the point A is the point where the object is situated earlier, which is situated at distance x from the center of the earth. So there are different things here that you should understand. Here the point P is the point where you are bringing the object, which is situated at distance r, and the object, say at some time, is at point A, which is situated at distance x, and you are bringing this object slowly to this point P. on this by traveling the distance on this particular path. Okay. Now gravitational force when the object is at point A, say for example you have this object of mass m which is situated at point A, then force on this object of mass m will be G. m1 is mass of earth, m2 is mass of that object upon square of the distance. Now distance between this center of the earth to the point where the object was situated is x, and square of it will be x square. So gmem upon x square is the force which is acting, which is explained here. Okay, F is equal to gmem upon x square. Okay. Now you want to bring this object close to the surface of the earth. So you want to have a small displacement dx on this path. Okay. So we can say that the object is brought from point A to point B by traveling a very small distance dx. Then work done, say dw for this particular small displacement is force into displacement. So force into dx. Now as you know, force is G MEM upon x square dx. Okay, so this is the small work done to bring the object of mass small m from point A to point B. Okay. Now total work done to bring the object from infinity. Okay. So when you want to find the total work done from point A to point B, then it is integration from A to B f dx. This is the formula for the total work done to find total work done that could be found with the help of this equation f dx from point A to point B. So your initial point is infinity, final point is point P where you want to bring this object. So the object is brought as such from infinite point to point P, but from intermediate A to B we have first calculated the work done. Now we are generalizing it, that you want to bring the object from infinity to point P, then the integration will begin from infinity to point P whose position vector is r or its distance is r. Then force is G MEM upon x square and the displacement is dx. Okay, small displacement you are doing. So that will give you total work done. Okay, that is explained here. Okay, it is gmem upon x square into dx. The integration begins from infinity to a point where you are ending. Now x square is x raised to minus 2. These are the constant quantities which are taken out from the integration. So you have x raised to minus 2. Now x raised to minus 2 has the integration x raised to minus 2 plus 1 upon minus 2 plus 1. So this becomes minus 1 upon x. So it is written here as minus 1 upon x. Okay. It is written here minus 1 upon x and the limits are substituted initially. Okay. So it is infinity to r. So first is the upper limit, that is r. Instead of x you write r. So it is written r here plus, because minus 1 upon r minus 1 upon infinity. Okay. So minus and minus becomes plus. So 1 upon infinity is 0. So it becomes minus 1 upon r. Rather this is r. Okay. So minus 1 upon r plus 1 upon infinity. That is why this step is written. So this work done becomes minus gmem upon r. Now according to the definition, this work done is known as gravitational potential energy of the body, which is now denoted by, instead of W you write capital U. Okay, so it becomes minus gmem upon r is the gravitational potential energy. Okay, And if the object is on the surface of the earth, so you are having the object on the surface of the earth, so finally you are placing it on the surface of the earth and you are bringing it from the infinity, then the final distance from the center of the earth will be equal to radius of the earth. So instead of this small r which we have written here, we have to write capital RE when the object is on the surface of the earth. So it becomes minus GMEM upon RE. Okay.